so in this video we're going to go over the second part of section 4 for exam number 1 in relation to limit evaluations. So in this problem set we have 3 problems. So let's start with number 4. So number 4 we have limit of x as approaches 2. And then we have 1 over x plus 2 minus 1 over 4 over x minus 2. So what do we want to do first? So we want to plug in the 2 into the expression in order to see if this is a non-determinate form, or if we can get the answer right off the bat. So in this case we can do 1 over 2 plus 2 is 1 over 4 over 2 minus 2, which in this case is 1 over 4 minus 1 over 4 over 0, which in this case just gives 0. 0 over 0. So now that we got that this with using direct substitution is indeterminate, we want to manipulate this expression in such a way that we can simplify it and then find the answer by using direct substitution later on. So what we can do in this case, we can apply the lowest common factor of these two fractions to each term in order to subtract the two fractions together. So in this case we can do 4 times 4 over 1 times x plus 2 and then minus 1 over 4 times x plus 2 times x plus 2, all that over x minus 2. So now we would have 4 minus x plus 2, all that over 4 times x plus 2. Actually, move this a little bit to the left, so we'd have 4 times x plus 2, just like that, over x minus 2. So this we just simplify to 2 minus x. You can just rewrite it as negative x, oh sorry, not negative 2, negative x plus 2 over 4 times x plus 2 over x minus 2. And now, since we have two fractions divided by another fraction within a fraction, we can just use copy that flip. So in this case we'd have negative x plus 2 over 4 times x plus 2 minus the reciprocal of this, so we'd have 1 over x minus 2 in this case. Or sorry, times, not minus. Could be because you're applying copy that flip, so you'd be multiplying in this case. Now what we can do is we can just rewrite this slightly, so we can do negative x plus 2 times 1 over negative x plus 2. So we take out the negative out of this expression, and then we do this first term over 4 times x plus 2. So now these two cancel out, so we just have the limit of x approaching to 2 of 1 over 4 times x plus 2. But keep in mind this should be negative, so it would be limit of x approaching to 2 of negative 1 over 4 times x plus 2. And then we can just use direct substitution, so we plug in 2 into the expression, so we'd have negative 1 over 4 times 2 plus 2, which would just give us negative 1 over 16 in this case. So this should be the final answer for the first part of the problem. Now the second part of the problem, second problem in this case, we have limit of x as approaches 2 of x to the power 2 plus x minus 6 over x squared minus 3x plus 2. So we can just first use direct substitution. So we want to do, we want to plug in the 2 value over here. So we do 2 to the power of 2 plus 2 minus 6 over 2 to the power 2 minus 3 times 2 plus 2. So in this case, we just get 4 plus 2 minus 6 over 4 minus 6 plus 2, which then in turn just gives us 0 over 0 in this case. So now that we found that this is in the undefined or just in the indeterminate form, we want to rewrite this limit, so we can just simply factor these two expressions out. So we can just do limit of x approaches to 2 of x minus 3, sorry, x plus 3, and then x minus 2. And then over here we can just also factor this out, so we can do x minus 1 times x minus 2, just like that. And now these two cancel out, so we essentially just get limit of x approaching to 2 of x plus 3 over x minus 1. So now we can just apply the value of the limit directly into the expression. So by substituting it in, so we just do 2 plus 3 over 2 minus 1. So essentially we just get 5 over 1, or this would just be 5 for the answer, just like that. And then lastly, we have limit of x approaching to 1 from the negative side of the same expression that we had in the past. We have x squared plus x minus 6 over x squared minus 3x plus 2. Okay, so now this time, given that we have 1 from the left side, the direction of the x value within the limit doesn't really matter too much. It's just more so of the value. So you just want to think about in terms of like substituting the value in and like see if it like it's an indeterminate form. If it is an indeterminate form, you want to rewrite manipulate the function in such a way by rewriting it, or use the conjugate depending on whether or not you have a square root. So in this case, let's just do direct substitution. So we do 1 squared plus 1 minus 6 over 1 squared minus 3 times 1 plus 2. So in this case, we get negative 4 over 1 squared is 1, negative 3 is just negative, so negative 2 plus 2 is just 0. So this would be undefined. And given that this is undefined, we want to rewrite the expression. So we can just do limit of x approaching 1 from the negative side of x plus 3 times x minus 2 over x minus 1 times x minus 2. In this case, so these two cancel out once again, and now we just have the limit of x approaching to 1 from the negative side of x plus 3 over x minus 1. So now we just substitute this directly in, so 1 plus 3 over 1 minus 1. So now we get 3 over 0, which also makes it undefined again. So given that this makes it undefined, another way that we can approach limits, in this case, is usually by creating a table of values, or selecting a value of the limit that is 1, technically, but isn't exactly 1 in that sense. So like we want to, so given that the x is approaching 1, we want to get a value that is, 1 right here, but we want to get a value that is like close to 1. So we're close to 1 from here because it's approaches from the negative side. So we want to get a value like 0.999 because it is technically 1, but also not at the same time if you don't round down. It's not exactly right on the dot the same number as 1, but it is super, super close. So in this case, instead of just using 1 to substitute in to the expression, you can just use 0.999. We're very, very close to the limit in that sense. So we can just do 0.999 plus 3 over 0.999 minus 1, which then this is like 3.999, which is basically 4. But then here we get negative 0.001, which just gives us a negative 0 in that sense. So you have 4 over negative 0, or not negative 0, but like, yeah, negative 0 in that sense. But when you want to write a negative 0, you want to put it in the corner right here to signify that is negative. And since you have a 4 over 0 negative, this should just give you negative infinity. So negative infinity defines the limit of x approaching to 1 from the left side of x squared plus x minus 6 over x squared minus 3x plus 2. So this negative infinity should be the final answer for the last problem. So yeah, thank you.